All right, good morning, guys. Sorry I'm not with you today. Not feeling great, but figure we can go through this lesson together. Now, this lesson is titled Factoring Trinomials with a plus sign as the second sign. And the reason why I titled it that is because as we look, we have two signs. We have the first sign here, and we have a second sign right here. And this second sign is a plus sign. So all the problems in today's lesson will have that plus sign as the second sign. So what we're trying to do is we're trying to figure out what multiplication problem made this problem. So we're going to look at two examples and a bunch of try these for you guys to get some practice with this. And then you'll be able to work on the worksheet that I left for you. So first thing I just want to review before I do this problem is we did take this note in a past lesson when we were multiplying binomials together. And we found that whenever we took a binomial that had a plus sign in it, multiplied by another binomial with a plus sign, we always got a trinomial with two plus signs. So as we look at this first example that we have the two plus signs here. So that means that this must have came from two binomials that had plus signs in them also. But let's see how we figure it out. Okay. So the main thing that we're going to focus on is we're going to focus on this 8 right here. Okay? Because we want a pair of numbers that are going to multiply to make that 8. But then we want the same exact two numbers to add and make that 6. So what I do is I make a little X over here. And I always put this last number here, the positive 8, I put that up in the top. This is just a way of organizing my thoughts. And then I take this 6 right here, the middle number, the number that we need to add to make, and I put it on the bottom here. So again, I'm trying to multiply to make that number, and I'm trying to add to make this number. So the easiest way to come up with these numbers is to go through all the ways to multiply to make the 8. So over here, all the ways that we can multiply to make 8. Let's see, we have 1 times 8, 2 times 4. And those are the only two ways to do it. So now I ask myself, can 1 plus 8 make that 6 down there? No, 1 plus 8 equals 9. But the 2 and the 4, 2 plus 4 does make 6, and 2 times 4 does make 8. These are the two numbers I was looking for. So to write my answer, all I do is I make two sets of parentheses. I'm going to put an X in both. And where did those two X's come from? The X squared, because X times X is X squared. And now I'm just going to take my two numbers from over here, and I'm going to put them in. So a positive 2 and a positive 4. Because X plus 2 times X plus 4 will make X squared plus 6X plus 8. This is the answer right here. But how could I check myself to make sure that I did it right? Well, I could always FOIL it and see if it makes the problem that we had. So over here, just real quickly, just to prove it, we're going to check our answer by FOILing. So first pair, X times X is X squared. Outer pair, X times 4 is 4X. Inner pair, 2 times X is 2X. And last, or the leftover pair, 2 times 4, which is 8. We have our like terms in the middle here. So we get X squared plus, combining those makes 6X plus 8. And if we look, that's the same exact trinomial as we had up here. So that's the way to do it. So make sure you get this down into your notes. And the next slide on your notes is a try this. So pause this video right now and go ahead and try the video. So I am going to go through and I'm actually going to do it now. But you should have paused and tried this out first and see if you got it first. So again, I'm looking at that 16. I'm making my little organizer. I know I want to multiply to make 16. I want to add to make 8. So 16 is 1 times 16, 2 times 8, 4 times 4, and that's the only way to make 16. So if I look, 1 plus 16 does not make 8, 2 times 8, 2 plus 8 does not make 8, but 4 plus 4 does make 8. So my two numbers in here should be 4 and 4, which means that my answer should be x plus 4 times x plus 4. Now, if you notice, these are both exactly the same. So this is a special situation. Whenever we get to two binomials that match just like that, we can rewrite the answer as x plus 4 squared. So for right now, since we're just starting to learn this, I'm okay with you leaving it like this, x plus 4 times x plus 4. Or if you want to be super cool, x plus 4 squared. Okay, again, the next problem is a try this. So pause it, try it. Whenever you're done, then hit play again so you can see if you did it right. I'm just going to move on to doing it. So again, you should have paused. You should be trying this before I do it. So again, making my organizer. I'm multiplying to make 40. I'm adding to make 13. So I got 1 times 40, 2 times 20, 4 times 10, 5 times 8, and that's it. That's the only ways to make 40. 1 plus 40, not 13. 2 plus 20, not 13. 4 plus 10, not 13. Close though. 5 plus 8, 13. So 5 and 8 go in here, which means that my answer is x plus 5 times x plus 8. Perfecto. Again, we have another try this. So pause it, try it, and then play after you tried it. So you should have paused. Here we go again, making our organizer. Multiplying to make 6, adding to make 7. All the ways to make 6. 1 times 6, 2 times 3. Now 2 times 3 is the way most people think of it right away, but 2 plus 3 is not 7. 1 plus 6 is 7. So those are our numbers, 1 and 6. And believe it or not, a lot of people forget about 1 times 6. So our answers are x plus 1 and x plus 6. Alrighty. Now we're on to example 2. So what's different about example 2? Oh, let's see if you noticed it. Well, like we said, every problem's going to have this plus sign as a second sign. But that minus sign in the front, that's what's different. But let's go back to these notes that we took before. We have these patterns. The minus sign is the first sign and plus sign is the second sign. Comes when you do a binomial with a minus times a binomial with a minus. So we know our answer is going to look like that. Now let's think about why that is, because we're still organizing it the same way. We're trying to multiply to make positive 10, but now we're trying to add to make negative 11. So if I go through all my ways to make 10, 1 times 10, 2 times 5, 1 plus 10 does not make negative 11. It makes positive 11. 2 times 5 does not make 11. It makes 7. But isn't there a second way to multiply and get positive 10 instead of just doing a positive times a positive? What if I make this a negative 1 times a negative 10? Negative 1 times negative 10 still makes a positive 10 because a negative times a negative is a positive. But now negative 1 plus negative 10 makes negative 11. And again, negative 2 times negative 5 would also make positive 10, but that makes negative 7 when I add together. So I want to use negative 1 and negative 10. So now my answers go x minus 1, x minus 10. If you put plus -1 and plus -10, I'm okay with that. But here's our -1, and here's our -10 from right over here. And if I FOIL it, just to prove that this works, x minus 1 times x minus 10 first gives me my x squared. Outer, x times -10 is -10x. Inner, -1 times x is -1x. And last, -1 times -10 is positive 10. Put together my like terms is going to give me x squared. -10, -1 is -11x plus 10. All right, as you see, same exact trinomial as we started with. So the negative works. All right, so now next one's try this, and we got a couple more try these, and then we're done with the notes. So pause and try it. So again, I'm over here. I'm multiplying to make positive 125. I want to make -30 when I add. So now I have to find all the ways to make 125. Now, you can start writing all the ways to make 125, which is fine. But if you happen to know that, 5 times 25 makes 125, you can skip right to that one if you know it, because you can see, if I make these both negative, -5 times -25, that's positive 125, and -5 plus -25, that's going to make -30. So -5 and -25 are my numbers. All right, so that means my answer is x minus 5, x minus 25. Now, some of you at this point may be asking, Mr. Wilson, what if I put x minus 25 first and then x minus 5? That's fine. Commutative property of multiplication. It's allowed. 2 times 3, 3 times 2, same thing. 5 times 25, 25 times 5, same thing. Okay, so the next one's to try this. Again, pause it, and then try it, and then press play again. So you should have paused. Hopefully you're following instructions. We're multiplying to make 32. We're adding to make -12. So I'm thinking to myself, okay, I know 1 times 32 isn't going to do it. Even if they are negative, it's going to make -33. A common way I'm used to doing is 4 times 8. And if I make them both negative, -4 plus -8 is -12. So -4 and -8. So x minus 4, x minus 8. Okay, next one's try this again. So pause it and try it. You should have paused. Okay, so positive 72, making -38 when I add. Now, the most common way people know 72 is 9 times 8. But even if I make these negative, they don't add up to make 38. So this is not the right numbers. So keep going through. Well, 1 and 72, but I know that's not going to work. That's going to make -73. What about 2 times 36? If I make them both negative, -2 times -36, positive 72. -2 plus -36, -38. So those are my numbers. So that's going to give me x minus 2, x minus 36. Okay. Well, that was the last one. All right, guys. So if you're still not sure on how to do what you're working with, just go back and ask a friend. Hit rewind on this. Check this out a couple more times. Ask the substitute. See if they can help you out. But you should have your notes filled out now, and you should go back and try the worksheet now. And again, remember, we're only working with these 2 patterns. This pattern's for another day. So good luck with everything. I'll see you tomorrow.